Bismillahirrahmanirrahim. So let's start with the today lecture. In this lecture, we will discuss the different types of the nuclides. And in the previous lecture, we have already studied the term nuclide, which refers to a specific nuclear species identified by a mass number. So here mass number is important and the atomic number is of course important, but remember whenever is the same atomic number, the nuclide uh, and or the element is not going to change. That means if there is a carbon 6 and when the atomic number is 6, then it must be a carbon, or if you say it is a carbon, the atomic number must be a 6. So but here in nuclear chemistry, the mass number is also very important and you can differentiate with respect to the mass number. And we uh, today are going to describe the different types of the nuclides. So the first one is the isotopes, as iso means same and topes mean the protons, as you can easily remember this terminology. That means iso means same and topes p is appearing, p is the protons. That means if the nuclides are having the same number of protons, they are called isotopes to each other. And even you can say the if there is the same atomic number, then these are also called the isotopes because the atomic number and the number of protons are the same. So one example is given over here. Let's suppose we have the three nuclides. One is the hydrogen 1, hydrogen 2, that is also called the deuterium, and the hydrogen 3, which is also called a tritium. So how can you calculate the first, the number of protons, neutron, and the mass number, and then you can decide which one is the nuclides, either they are the isotopes or something else. So first is the hydrogen, atomic number is 1, mass number is 1, so number of protons are 1 because the atomic number is 1 and the mass number is also 1. And the neutron, you can calculate mass number minus atomic number. So this is the 1 minus 1 equal to 0. There are no neutrons in case of the hydrogen 1. For hydrogen 2, the number of protons are same. As I have said before, whenever it is the hydrogen, atomic number must be 1. Or if you say which one nuclide or the element is having the 1 atomic number, it must be a hydrogen. So proton are 1. Now the mass number is 2 and the number of neutrons 2 minus 1 is the 1. And the third example is the tritium, atomic number 1 and the mass number 3, number of protons are 1, number of neutrons are 2, 3 minus 1 is the 2, and the mass number is the 3. So what is common over here? It is the three nuclides. Now we can say these are the nuclides having the same number of the protons, and that's why these are called the isotopes. And if you want to expand this definition, you can also say the same number of protons and different number of the neutrons and different mass number. These are also called the isotopes. So here the protons are the same. If you have a look on the number of neutrons, 0, 1 and 2, neutrons are different. And if you have a look on the mass number over here is 1, 2, and 3. The mass number is also different, neutron are also different, but the number of protons will be the same. These type of the nuclides are called the isotope. The second type is called the isotones. So this is the same, iso means the same, tones, n is repeating over here, that is called the n. When it is the same n mean the number of neutrons, then these nuclides are called the isotones. So example is given over here, boron 12 and carbon 13. And this is the atomic number of boron, mass number 12, number of protons are 5, number of neutrons are 12 minus 5 equal to 7, and the mass number is 12. And other example is the carbon 613. Protons are 6 because the atomic number is 6. Number of neutron 13 minus 6 is 7. And the mass number is the 13 as given over here. So what is common similarity in these two nuclides? The both are having the same number of neutrons. So you can say these are the isotones to each other. And if you want to expand this definition, you can also say the same number of neutrons, but different number of protons and different mass number. These are called the isotones. So it is very easy to remember if you just have in mind the sound of these terms isotones, same number of the neutrons. The third example is the isobars. And what is left? We have already studied same number of neutrons, same number of the protons, and what is left? Only the mass number is left over here. So if the nuclides are having the same mass number, these are called the isobars to each other. So let's suppose this is the example of carbon and boron. Mass number 12, mass number 12, atomic number 6, atomic number 6. This is not going to change, but the mass number may be variable. But here in these two nuclides, the mass number is same. That's why these are called the isobars to each other. And again, if you further expand this definition, and even you can calculate, these are the number of the protons. Protons are the different, and 12 minus 6 will be the 6, 12 minus 5 will be the 7. Number of neutrons are also different. So isobars are having the same mass number but different number of protons and different number of the neutrons. The last and fourth example is the isomers. Again, if a nuclide is the same, and this is the special example. Let's suppose if there is a carbon 14, atomic number is 6, and the mass number is 14, and there is another nuclides with the same atomic number and the mass number. So then there is no difference between the atomic number and the mass number. So what would be the difference in nuclear chemistry? They may have a different energy or emitting the different gamma ray radiations. So they are having a difference in energy but not having the difference in atomic number or the mass number. So such type of the nuclides are isomers to each other. So I have given you the example, the carbon 6, 14. One nuclide is having the, let's suppose the energy is 2 mega electron volt. Another nuclide which is having the same mass number and the atomic number, that means carbon 6, 14, but only the difference in energy is 4 mega electron volt. So one is having 2 mega electron volt, other one is having the 4 mega electron volt. Then these nuclides are called the isomers to each other. So this is all about the types of the nuclides. These may be called as the isotopes, isotones, isobars, and the isomers to each other. So this is little bit exercise. Let's suppose if you are having these four different carbon nuclides, carbon 11, 12, 13, and 14, and you have to decide what type of the nuclides are here. Either these are the isotopes, isobars, isotones, or the isomers. So first you have to calculate the number of protons, neutrons, and the mass number, and you can easily decide what we have already explained. But you can also decide looking at the nuclides. Here the carbon is repeating. That means the number of protons are the same because carbon is having this atomic number 6. So protons in four type of the nuclides are the same. So there is only one type of the nuclide, and you can call it the isotopes, which are having the same number of the protons. So these are the isotopes to each other. And if you do not get this point, you just calculate as we have done before in the previous slide, and you can say there must be a same number of protons or different number of the neutrons and the mass number. So mass number is of course different over here. atomic number is the same, and then you must have a different number of the neutrons in all four cases. Another example is the nitrogen 13, 14, and the 15. This is the same example. These are also called the isotopes to each other because the atomic number for the nitrogen is 7. Nitrogen is repeating, and the protons are the same, mass number are the different. When you subtract 17, 13, 14, and 15 minus the atomic number, which is the 7, the neutron would also be different. So same number of protons, same number of neutrons, same number of protons and different number of neutrons, and the mass number, these are also called the isotopes. Another example is the iodine 123, 124, 125, 129, and 131. These are also the isotopes to each other because the proton remains the same and the mass number is different. When you subtract the atomic mass number from the atomic number, then number of neutrons will be different. So these are the isotopes to each other. This is the last one exercise. This is the sulfur 36, chlorine 37, argon 38, potassium 39, calcium 40. So if I ask differentiate which one are the isotopes, isobars, isotones, or the isomers, so what would be your answer? The first thing is, if you are not getting the point, you can calculate the number of protons, neutron, and the mass number. And here I am also judging the example because here the symbol is not repeating, element is not repeating. That means one nuclide is different from the other nuclides, so the protons are different. That means atomic number is different, so these nuclides are not having the same protons, so that means these are not the isotopes. So second, the mass number is different: 36, 37, 38, 39, and 40. So if the mass number is different, of course these are not the isobars to each other. So energy is not given over here. We do not know the energy, and even the one nuclide is not repeating over here with the another nuclide. So these are also not the isomers. So what is left? These may be the isotones. So of course these are the isotones to each other because of having the different number of protons, different mass number, but the same number of neutrons. These are the isotope to each other, and you can calculate and verify what I have explained over here. So this is our today lecture. See you in the next lecture.